I hope everyone can see that. I apologize. I'm going to turn my camera off just in case it helps cut down on any sort of internet connectivity issues. I'm joining you from China, so I'm actually in an area where the internet is not very good. But, I'll keep the camera on. If it gets a little weird, I'll turn it off a little bit later. But anywho, I'll go ahead and get started. So my name is Adam John Privitera. I'm an assistant professor of psychology at Wenzhou Kane University, which is in the People's Republic of China. It's on the East Coast, kind of close to Shanghai. Today, I'm going to be describing some results from a recent project that we conducted focused on the relationship between executive function and academic performance. Now, the assessment of academic performance, to include prediction of future performance, is probably don't have to tell you, it's a multi-billion-dollar industry. And this is something that's almost culturally universal. We assess and we make a number of decisions based on how well someone does in their previous learning and how well we think they'll do in their future learning. And institutions all over the world, they rely heavily on a range of different assessments, typically administered in pen and paper format, although increasingly administered through computers, in order to make these decisions about if a student meets the standard to be admitted to a program or to be advanced within a program. In the psychological sciences, we typically focus more on psychological constructs, such as intelligence. And there's a considerable amount of work looking at the relationship between intelligence and academic performance, and unexpectedly, or rather expectedly, identifying positive correlations between fluid intelligence and academic performance, operationalized in a variety of different ways. More recently, however, the focus has shifted away from intelligence as a predictor of academic performance and looking more at these dissociable components of executive function. Now, for the purpose of our work and the majority of the past studies on this topic, we operationalize executive function as a set of somewhat distinct cognitive abilities that are attentionally controlled. They're controlled by attention. And we subscribe to the framework of Miyake and colleagues to include the more recent reconceptualization by Friedman and Miyake in 2017, where we distinguish between at least three components of executive function. So inhibitory control or inhibition, your ability to ignore distractions, shifting, which is your ability to switch between different ways of thinking or mental sets, and then updating, which is you're monitoring and you are updating representations in working memory. I should again reiterate, we consider these to be distinct, but with some degree of overlap. And depending on whose theory you subscribe to, that overlap can be fairly substantial. And you see this when we look at the correlations on performance in tasks that are aimed at measuring these separable dimensions of executive function. Should come as no surprise that when we consider the significance of executive function, there is in fact an established link between executive function, specifically inhibitory control, and academic performance in both quantitatively and qualitatively focused disciplines. Now, unfortunately, the extant literature is quite mixed. There are a number of mixed findings and some disagreement over what aspect of academic performance is related to these differences in executive function, and which dimension or component of executive function is the one that is most related to academic performance. Additionally, the majority of this work has actually been conducted in samples from Western countries. There's very little work looking at samples from countries that are in Asia, specifically the People's Republic of China. And to that end, we wanted to fill that gap. We wanted to explore whether or not this relationship existed in a culture that's not widely studied, and to use measures that were a little atypical in how executive function is measured in these studies, which is often through teacher reports in younger samples or parent reports, and even self-report. These are subjective measures of executive function. So to that end, we designed a study aimed at looking at whether academic performance could be explained by differences in inhibitory control and or attentional function based on the representation in the extant literature. And to investigate our question, we recruited a sample of high schoolers from a bilingual English immersion school in the southern Chinese city of Shenzhen. I should mention that the reason we reached out to a school of this kind is that the reporting of grades in mainland China is quite different in public schools, and it's actually very difficult to get access to reliable academic data. There's not a strong culture of sharing, especially with researchers outside of the mainland. At the time, I was based in Hong Kong. I should mention that we had ethical approval to conduct this study, and it was granted by the University of Hong Kong. In terms of our dependent variable, we operationalized academic performance in the way that most previous studies do. We use GPA, and we use GPA on a scale of 4 points. This avoided some of the limits associated with focusing on just one particular discipline. Some studies use standardized assessments of performance in reading or mathematics. We feel that the use of GPA actually avoids some of these issues where we can make perhaps broader statements about the relationship between executive function and academic performance. It's a more inclusive definition of academic performance. And in order to assess differences in cognitive function, we had participants complete 2 different behavioral tasks, which allowed us to compute multiple indices of both inhibitory control and attentional control, as well as processing speed, which was one of the variables we controlled for. First, we had participants complete a 2-color Simon task to measure differences in inhibitory control. For those of you that are not familiar with the Simon task, it is a task in which there's conflicting information between where a stimulus is presented on the screen and how a response is mapped to either a button on a flat surface, just like a regular standalone button, or in our case, it was a computer keyboard, where sometimes participants would be told to press a right button if they saw a blue square, and that blue square was on the right side. So it would have no conflict. But if that blue square is on the left side, there is conflict. And participants are slower on these incongruent trials where conflict is present. Through the Simon task, we were able to compute a measure of inhibitory control as the difference between incongruent trials and congruent trials, as well as a second index as the difference between incongruent and neutral trials. There's debate in the field regarding whether the typical way we compute this index, the difference between of incongruent and congruent trials, is actually not the best measure, because congruent trials can actually facilitate faster responses. So we computed both indices. Additionally, we took the average response time on neutral trials as our measure of processing speed. We also administered as a second measure the attention network task. This is very similar in what it's measuring to the Simon task, but it has the additional benefit of allowing us to compute 3, or in our case, we limited it to only 2 indices of attentional control based on contrast between different cue conditions. The cues can be in a variety of different forms. There's no cue trials, central cue trials, double cue, and spatial cue trials that differ in whether they're providing temporal or spatial information about the upcoming presentation of a stimulus. Together with the mix of congruent and incongruent trials, we computed additional indices of inhibitory control and processing speed, as well as these 2 indices of attentional control, one for alerting and one for orienting, based on the original work from Fan et al. In 2001. To summarize, we had a range of different indices for cognitive function, 4 indices of processing speed, which were derived from neutral trials, 2 of inhibitory control, and then these indices for alerting and orienting for attentional function or attentional control. We also measured a range of additional variables that are known to influence both performance on Simon, flanker, and related tasks, as well as academic performance, including sex at birth, age, socioeconomic status. We took parental education level as a proxy for SES, English language proficiency, because differences in academic performance in an English immersion school could be explained by differences in second language proficiency. And then obviously fluid intelligence, as it's probably got the strongest relationship with academic performance. And we wanted to make sure that any differences we saw were certainly accounting for differences in fluid intelligence, which we assessed using what's called the CAT-4, which is a cognitive abilities test. It is a standardized assessment that's widely used in the United Kingdom. All of our data were collected online using the Gorilla Experiment Builder, and this decision was made in light of the restrictive pandemic policies in mainland China that prevented the collection of in-person data, even if there was just a single case in a city. All of our data were analyzed using Jamovi, which is an open source statistical package. We used a series of linear regression models in order to model what best predicted differences in academic performance. Onto our results. I first want to bring your attention to the fact that only one index of cognitive function or of executive control was actually related to academic performance. And it was the index of inhibitory control that was calculated as the difference between in neutral trial task or flanker trial from the attention using the no, actually the same thing as a classic error task. Multiple linear regression revealed that this index of inhibitory control accounted for an additional 10% of variance in academic performance after controlling for sex at birth, age, socioeconomic status, English language proficiency, nonverbal intelligence, and processing speed. In total, this model accounted for around 50% of the variation in academic performance. So why would improved inhibitory control result in possibly influence? I didn't mean to imply a direct relationship, but why would it influence performance in school? If you have the idea is if you have improved inhibitory control, you can better focus on tasks, you could ignore distractions. So this isn't groundbreaking. It aligns with a lot of the existing theoretical and empirical support for a relationship between specifically inhibitory control and academic performance. It also aligns with disorders where we find students often have lower academic performance, and the symptomology of the disorder can include issues associated with differences in something like inhibitory control, although ADHD is certainly way more than just differences in inhibitory control. Some unexpected things we found, something that deviates a bit from the previous work, is we only found that this relationship was between one index of inhibitory control, and that is in the cognitive literature what you might call a more pure index of inhibitory control, using the difference between incongruent, these conflict trials, and neutral trials, as opposed to congruent trials that may facilitate faster responses. We also find that in this particular age group, there is at least some evidence that inhibitory control loses its predictive power. Our work conflicts with that, but again, the majority of this work is in samples that are from Western countries, and there is a fairly strong, I guess that's not overstating the evidence, there's a fairly strong belief that there are cultural differences in the development of different aspects of executive function to include inhibitory control. Specifically, parents in collectivistic cultures are thought to be more focused on having their children inhibit individual desires, which may in fact drive an earlier maturation of something like inhibitory control. We also didn't find, I guess surprisingly, we didn't find a relationship between any measure of attentional control and academic performance, which may relate to how we measured attentional control, which was limited to only indices of alerting and orienting, which may not be the most relevant pieces of the complex construct of attentional control. We feel that our value in this research is that it contributes to additional understanding of how executive function influences performance in the real world, especially in samples that are understudied. We found that, at least in the context of using traditional behavioral tasks, you can possibly use this as an unbiased index that avoids issues associated with test anxiety and other things that confound performance on typical pen and paper assessments. And it also highlights that there is possibly potential in developing some sort of programs to develop or improve inhibitory control in students that may have an impact on their academic performance. However, we are limited So the direction, and I didn't mean to imply causation earlier, but we don't know the direction of the relationship. Do students who are better at academic performance have better inhibitory control, or is it the other way? We don't know. Our study was not designed to ask that question. Additionally, we use GPA, and while this partner school was very transparent with their academic data, we know that there are subjective influences of relationships between students and teachers that may impact on GPA in ways that are not related to academic performance. We're currently collecting externally validated performance on IGCSE and A-level assessments to see whether or not this relationship holds. Finally, our finding could be culturally specific. Again, there are differences in how different components of executive function develop in different cultures. Additionally, there are differences in how grades are assigned in different cultures. So the way that students in one culture are assigned grades may actually be different in ways that could make what we find specific to one culture. Our references, and just to acknowledge, this project was funded in part by a small grant from Cauldron Science that allowed us to host our task online. And I would like to thank our participants, school, coordinating faculty. I also want to acknowledge that the full-length manuscript of this study that I just described was just recently published in Child Neuropsychology. So fortunately, we have made it through that process. It's a bit faster than I expected, and looking forward to any questions you might have. Thank you.